Hello everyone. So today we are going to talk about equation of plane again, but this time we are going to look at how to find the equation of plane that is perpendicular to another plane. So if you remember from the previous example, we have 3 points here and we find the equation of plane that connects all these 3 points. And then now what we want to do is actually find another plane which is given in green here, which is exactly perpendicular to the plane in this purple color. So let's see how to do this. Alright, so the first thing we need to ask ourselves is whether the plane that we are trying to find has to go through any given points or not. So in the previous example, we want to find the plane that connects the 3 points. So basically, the plane will have to go through all these 3 points. So now, when you want to find another plane perpendicular to this original plane, we have to see whether there is any need to go through either of these points. So let's say now for a first example, we do not need to have this green plane to go through any of these points. So in this case, this is a rather simple task to do. First, by taking stock of the fact that when you have the equation of plane given by this purple color, which is this one, remember we can find the point that is directly perpendicular to the plane by looking at the component in front of the x, y, z. So in this case, the point that is perpendicular to the plane is precisely the point 6, 4, 7. So the 6, 4, 7 is this point here. So you will see that this is directly perpendicular to this plane. So now for the first example, we are going to find a equation of plane that is perpendicular to the one in purple, but it will go through this green point. So now let's look at the basic idea on how to create a plane perpendicular to a given plane. So let's go to this example where we have 3 points and we already find this plane that connects all these 3 points. And from this equation of plane, you can find the point that is perpendicular to that plane, right? We have seen how to do this. And then now what we need to do is to write a vector that connects this point, the green color here, to a point on the plane, the one that is given in blue circle. But the problem now is that we do not know what is this point, right? So how do we write the equation of plane? So the steps is easy. You just remember the vector. When you write a vector, it means you take the point that you want, let's say x, y, z, and you will minus with the coordinate or the point that you have here. So the tail, this is the head, you take the head minus the tail. Right, so assuming now you manage to find this vector, then the next step is that you need to find a vector that is along the plane. So here we can make use of the previous example. Remember we have the point P, Q, and R. And the first step we did was to actually find the vector that connects P to Q and P to R. So here we can use PQ instead. Now the next step is basically rather straightforward because here you see this vector and this vector PQ, they are perpendicular. So you take the dot product between the two of them and then you set the scalar product to 0. It should be 0 because they are perpendicular. And from there you can get the equation of plane that you want. So let's look at the example that we had previously. So the question now was to find an equation of plane perpendicular to this line, right? So we will use the same coordinate P, Q, and R. And from the equation of plane that we had previously, we know that the point perpendicular to this plane is 6, 4, 7. So now the next point is to find the vector that connects this point to a point on the plane. And here you can take the head minus the tail, the coordinate of the head minus the coordinate of the tail, and here you have x minus 6 plus y minus 4j plus z minus 7k. Okay, now this is done. And we already have PQ, which is given here. Now when you take the dot product between the two and set it to 0, you will get this equation of plane. So you have x minus 5y plus 2z. So in the next slide, we will see how this plane is going to look like. Alright, so now we are back to the plotter and we want to try to see whether our equation that we get earlier is correct. So let's see here, we have the plane in purple. This is the original one. We have the 3 points, so this plane connects all these 3 points. And then from there, the equation of plane, we can get a point that is perpendicular to the original plane given in green color here. And then from there we got another plane which is perpendicular to the earlier plane. So on the left hand side here, you see I've put the values for the plane. You have 1x minus 5y plus 2z equals to 0. So from here I get this plane in green color. So here you see that the plane is in fact perpendicular to one another. So this plane is going through the point here. So the next example, we are going to look at how to get this plane if, let's say, we have to go through either of these points. Alright, so till then, I hope this has been good for you. So try to do some exercises and familiarize yourself with this equation of plane.